All right, so I think I've got all that set up right now. So if we go and we look at today's content thing, remember by Friday you have to have taken exam 3. Hopefully most of you have already taken it, so it's a time over the weekend taking it. If not, you're waiting till the last minute, that's fine too. You have till April 14th, which is Friday, to take it. I gave you over a week with this test, so there's no excuses for not having it done. All right, that being said, I want to move into project 3. And if you notice on the content page here, there is one section that says very, very clearly in big capital letters, read me first. It amazes me how many of my students over the course of the last couple of years do not actually read me first. So let me read it to you. Project 3 requires several files to be downloaded and used to run this program successfully. These files are in the resource tab on the content page. Download the files into a folder together. I suggest that you create a folder on your desktop or somewhere. Create a whole brand new folder that's label it Project 3. That way it's all going there. You don't have to worry about mixing it with other stuff. You put it on the desktop, we can find it easily when you come and ask me a question about it. But if you're one of those people that doesn't like stuff on your desktop, pick another spot. That's fine. All right. One of them is a zip file with images in it. When you unzip this file, you want to extract those images, take them out of the folder. The zip is going to extract them into a folder, and you can leave them there, but if you do, you're going to have to do folder name / file name when you do your pictures. My suggestion is just grab them and drag them back out into the main folder. It is, but if I don't say it, somebody's going to mess it up. We're going to discuss this in class. We're doing it right now. I actually am more than happy if you brought your computer with you to help you set this folder up before you leave today. And to check that it's all set up appropriately. If you want to go log into CourseDen and start downloading files, and we'll put them all in the right place. I'm cool with that. We're going to do that today. And I just realized there's a typo right there.
Made it all the way to the end.
Made it to the last flipping word, and there's a typo. All right, so save that and fixed it. All right, so that's the read me first. File organization for this one is going to be extremely important, or you'll be frustrated.
File organization.
All of it in the same folder.
Do that.
If you don't have those files in the right place, we have to go back to those task names that I told you about. And let's not do that. Cause a lot of confusion. It'd be easier for me if you do it this way too, because I'm just going to take your .py file and throw it into my folder, and all the resources are going to be there for me to grade it. Let's be honest. If you use path names, it's not going to work when I grade it because you're only submitting the .py file.
We make it so it's hard coded.
If you hard code stuff in, be like the web page projects I just graded, where none of the links work because they're hard coded to the student's C drive. Well, your C drive and my C drive are completely different things. So anyway, things to learn. So I do have a PowerPoint we're going to go through, but this is the resources tab, and they have things here for you to download. We're going to use bits and pieces of a lot of these files, but if you go ahead and download them, you'll have them. You can actually skip the book test py file if you want to. We probably won't use it. It was from the previous textbook we were using. But if you want to grab it, look at it as just an example of some code. Up to you. We are going to use CImage instead of image. Image.py is a module that you can import. You can do import image what we're gonna import C image, we're gonna talk about the PowerPoint in a minute. The reason is it's a slightly simpler version of the image files. And it gets rid of some of the stuff we don't really need, and it makes it easier for you guys to use. They're both modules, one's just slightly improved or simplified. And then, like I said, the images.zip is the pictures that I'm going to use in my examples, and I'm going to use when I grade your thing.
Those, all four of those files need to find. Download.
If you click on those links, they should automatically down. Let's see. Let's make sure. Yeah, see, if you click on it, it downloaded it. I don't know that you need the second one. Like I said, I think I've eliminated it, but it's there for your reference if you want some more examples. The images.zip is gonna come as a zip file, and when you click on down here, you're gonna have to extract it. Do you all know how to extract a zip file? Anybody want me to walk you through extracting a zip
Never
file?
tried, it sounds like.
Okay, all right. So first thing I'm gonna do is I'm gonna come over here to the desktop and I'm gonna create a new folder. And I'm gonna call it Project 3. Just where I have a place to extract to. I'm gonna click on this. If this is all Windows, if you have a Mac, I'll come and try to help you figure it out. I don't use Macs that often, but I'm sure we can figure it out. If you're in Windows, if you click the pink extract button at the top, it gives you an extract all option. If you click that, it brings up this window. And default is to extract it exactly where it's at. We don't want to do that. We want it to go to our folder. So I'm going to click the browse button. I'm going to go to the desktop. I'm going to click Project 3, select that folder, and then I'm going to go extract.
Did you just do this with one file or all of them?
I did it with the zip file. I extracted all of them at one time. And as you can see, now I have 5 pictures. They're slightly dated pictures. They're the solo one. Well, that movie's been out a while. Okay. All right, fine. At the time, it was newer. So after I extract that, if I go to my desktop to the Project 3 folder, they're all in there, right? And, you know, we tried to do a mixture of themes. There's a sports one in there for the World Cup. There's a couple of sci-fi geeky pictures. There's a couple of just random nature pictures. You can use your own pictures. You can put more pictures in this folder and use whatever you want to. These are just the ones that I can give you. The pictures in this particular case were you can only use GIFs. .gif. The only thing that's going to work. So if you do use a different picture, make sure it's a .gif. Anyway, they're there for you to use. This is where I'm going to save my Python project also. So when I go to idle, and I go File, New File, we do File, Save As, and I'm going to go click on Desktop. I'm going to go to Project 3, and I'm going to click Open, and I'm going to put it in here. And I'm going to save it. So now it's all in the same folder, right? So again, to prove that point, I now have Project 3 in there. And when I want to open it, I'm going to open it from there and not let idle save it in its default saving spot. All right. We good so far? So far, so good? All right. So back to this. So if I go back to content, we've looked at the resources. We've looked at the README file. The assignment's right here. You're going to put the dot. I only want the .py file. Do not do a zip and zip up all the pictures and stuff. Same as all before. Just give me the .py file with your first and last name and the title. Because I'm gonna put them all into my folder and I'm just gonna run them all from my folder. Just go with me. Can you turn it in as a zip file and all that stuff? You could, but then it's annoying and yes. Because you didn't follow directions. All right. So lecture 8 images is probably not lecture 8, but that's how the file was saved. It's just a few slides where we're going to talk about pictures. I unzipped it and graded it. It's okay. You can it's just more work for you. It's not really that big a deal for me. I'm still just going to unzip it and go grab what I want to put it in my test folder. So let's talk a little bit about pictures in general. Because you need to know how pictures work before you can actually do a project on pictures, right? So we're going to process some images. Pictures are basically a two-dimensional grid. Kind of, remember Battleship, play the Battleship game?
Yes, the ancient ways.
The ancient ways, not the actual physical game, not the computer game. Or tic-tac-toe for that matter. So you have rows and columns. The picture has rows and columns. Each row and each column has index numbers. So you have X coordinates and Y coordinates. X is going to go across. Y is going to go up and down. In this particular case, pictures start with their 0, 0 coordinate, 0x, 0y, in the top left-hand corner. Yeah, I have to do the hand signals to make sure I get left and right. So if you're looking at this particular image, this first square is at position 0, 0. Right? Because index numbers always start at 0, right? So there's 1, 2, 3, 6 columns and 6 rows. So this yellow box is at position what? What's the X and Y position of this yellow box?
Here is as far as start at 0 down 3.
They start at 0. So that's at 3, 3.
Were you negative? Are you negative or minus?
No, pictures are different than the coordinates of the turtles. So it starts, so that's a good question. That's absolutely a good question. I should have said that clearer. So in an image, Y goes 0, 1, 2, 3, 4, and it gets bigger as you go down the image. No negative numbers in images. And same with X, it starts and it goes across the top. It goes from left to right, 0, 1, 2, 3, to the end. That make sense? Is that clearer?
Is it always assumed that it starts at the top left-hand corner?
Yes, it is defined that way in Python. It actually is defined that way in Java too. So you'll be able to carry your image knowledge to Java. It seems to be fairly similar. I know, odd that they're actually similar. So each picture, each pixel in your picture, because each dot or each square of your picture is a pixel. Each pixel knows where it's located in the picture. It knows its X and its Y location. It also knows how much red, blue, and green it holds. Then that red, green, and blue, or however, whatever order you put it in, defines the color of that pixel. Now we're going to talk a little bit about colors having to do with pictures too. So colors in pictures are defined by the mixing of the red, the green, and the blue. There's a reason when you see monitors and things and it says RGB values. The RGB is the red, green, blue. I don't think you see that as much now. Now it's more about resolution and refresh rates and stuff like that. But in the old days.
That's what you're doing.
Now, the odd thing or the
That is odd.
unique thing is if you notice when these colors are overlapping in this diagram, in the center where they all overlap is white.
Yes. That's in the spectrum.
So if you're an art major, you're gonna hate me. Because we've taught you throughout your childhood that if you mix all the pigments together, you get black. And the absence of color is white, right? We taught you this in kindergarten, right? When you were mixing your finger paints
Yeah,
together.
we get all that.
Throw all of that away. It's because we are not mixing pigments. We are mixing light. Now you need to think back to science class where you took the prism and you took a piece of white light and you put it through the prism and it created this beautiful rainbow because the prism broke the white light up into its component parts. So with light and pixels and anything projected onto your screen, the absence of color is black. The absence of light is black.
So it's 0, 0, 0, what?
0, 0, 0 is black.
Oh, right.
Yes. I've had some graphic art majors and some art majors in my classes, and this really just
Not on that
flips.
hill.
They want to die on that hill. But so if you want white, you want 255, 255, 255, because colors are represented in 8 binary digits. So that gives you 0 through 255, which is 256 combinations. So when you're mixing your colors, it gets a little wonky in your head because light mixes different than pigments. So if you want something to get brighter, you're probably going to increase numbers. When it gets darker, you're going to decrease numbers. And you do just the opposite in art. I have some artsy people in my family, and they're not happy with this. So if you click on that link, it does take you to this lovely little website where you can click on things and it'll show you different colors. You also can pick different shades and see what the mixtures of colors are. Hex codes are for web pages. We're not using hex codes in any of ours. We're using red, green, and blue. So, like I said, white is 255, 255. This is slightly red. This is completely black, So keep that in mind. Because we're going to be doing some stuff with colors. I also need you to keep in mind that purple doesn't truly exist as a defined color in Python. You usually say violet, but you can mix your own purple, right? Cyan is going to come back. Magenta is going to come back. And so we're going to do something with our pictures with red, green, and blue. I'm going to help you this week do those. Part 2 is going to ask you to do cyan, magenta, and I want to say yellow, maybe? I don't remember the 3 colors, but there's 3 colors. So this would be a good place to come back to and go, oh, here's my RGB values for those colors because you're going to need them. Hint, hint, you're going to need this slide. Take a picture of it. That's an excellent idea. Saw that. I'm okay with that. So I'm going to leave that minimized. We can come back to it if we need to. So we're going to be working with images. there is, like I said, an image file. You can import it. And once you do, you can open up a a picture. When we create an image, we use image.image like we did with the turtle.turtle. Same with the images because we're creating an object. So, and when we do that, we just need to give it the file name. If all of your pictures are in that folder, you can just type the file name .gif. This is a JPEG because it's image. We're going to switch in a minute. There's already some predefined functions. There's an API you can go to and look at some predefined functions like get width, get height. You can get a pixel at a specific location and it will go get that one pixel for you. And then you can take that one pixel and you can change that pixel.
Scope of the project, image.
See image, which you're going to download, which is actually, see image is a subset of image. So a lot of these things are interchangeable. The reason we're going to use C image, and we'll get to that again in the slides, but let me go ahead and tell you. The reason we're going to use C image is because C image allows it to draw and process in a way that you'll be able to see some of it happening and it won't be instant.
So does that mean when we're making image, we see image.
The only thing that's going to change is the import statement.
So the actual usage won't change.
Yeah, let me swap over. Yeah. So, that's still image. This one's using C image. So import C image, add image. Nothing really changes except the base files we're pulling from. It just gives us some more things to play with. I get tempted every now and then to go back and just make it all work on image, but I haven't done it yet. It's one of those situations where just do what I tell you to do because we need a subset instead of the whole thing. And so you get the image. Once you have the image, you can get an individual pixel out of that image, and then you can get the individual colors out of that pixel. Well, guess what? What I'm leading you towards. If I can get the colors out of that pixel, but it currently is, then I probably can set those colors too. So we're going to change some colors inside of our picture to make them have very, very simplistic filters over them. So you'll understand a little bit about how filters are created on the very basic of levels when we're done. And ultimately, we are going to take a picture and be able to turn it into a black and white photo. It's not going to be beautiful because it's going to be very simplistic. Because a truly black and white photo that we actually have is not truly black and white. It's grayscale. It does a bunch of scales of gray. We're just going to do black and white. It's not pretty, but it works. Could I teach you to do grayscale? Yes, and if you want to go above and beyond and figure that out, let me know. But it's not required. So images are a 2D table, so we're going to use nested loops to navigate. We're going to have one loop that's going to be the rows and one loop that's going to be the columns. So we're going to pull our nested loops together, right? Yeah.
I assume there was something you just said.
No. If we are changing every pixel in the picture, we're going to use a loop to touch every pixel.
Every pixel?
Every pixel. But we have loops, so it won't seem like it takes that long.
The number.
It's just a number.
Don't use okay.
Whatever, you have to pull all the editing software ideas that you have out of your head. We're doing it old school.
Good, I have no idea what you're talking about. So
Good.
I'll be great.
We're going to do this the old school way, one pixel at a time. Hey, look, just be glad that I am not making you practice this by doing it literally one pixel at a time without the loops.
Actually, no.
I have seen some teachers try to impress upon their students why loops are important by having them change a whole row of a picture, 1 pixel at a time, by hand without a loop. I'm not gonna do that.
Yeah, I'm sorry.
I like y'all too much. I value your time more than that. So what you're gonna do here, this is just an example of a nested loop, but it's really easy to set this up. They're using I and J here, but since we already know that the pixels are gonna be in X and Y, I'm okay with you changing your variables to X and Y. And that way, you know, if you're on the X column, which loop's doing what. So you could do X and Y, and then you know which loop is going in which direction. And for the how far in range we're going, if you're doing the whole picture, then you do the width and the height. Image.get width, image.get height. You might have to do -1 index numbers. So also, if you decide you don't want to do the whole picture, you want to say you only want to go halfway across, then you could still use the get width and get height, but then you divide it by half. Yeah, it plays the later portion of the project when you get down into this assignment kind of get, yeah. So, like I said, this project pulls all of the concepts we've done together in one place. It's not meant to be super hard, but it is going to make you think and do some planning because there's a lot to keep up with. Which is what you're going to find as you move forward in computer science, that the projects are going to get more and more in depth and you have more moving pieces to keep up with. So if you want to call it row and column, you can. If you want to call it X and Y, I'm okay with that. Normally I tell you not to use X and Y as variable names, but since we're dealing with the X and the Y coordinate of a picture, it makes sense here. That you see what I'm saying? I'm not grading you down for what variables you use in your for loops at this point. This example uses row and the abbreviation for column. That's fine. If you want to, that's fine too. And it doesn't really matter whether you do the row on the outer loop or the column on the outer loop. You just have to remember which one you're doing. So what's the difference, you say? Well, the difference is if you put the row first, that means it's going to go across and do 1 row at a time through your loop. If you put the column first, then it's going to do 1 column at a time. It just is a difference in which direction it's navigating. It essentially does exactly the same thing. You just have to make sure that you remember that height goes with the number of rows and width goes with the number of columns. Because if you reverse those two, and it's not a perfectly square picture, you might run out of indexes before you get finished. And then you'll get the index out of bounds error, and you'll go, I don't understand why this doesn't work, because you've got your heights and your widths mixed up. That honestly happens more often than you'll think, because you'll just be typing and or copying and pasting or whatever, and you'll put the wrong one in it. Or if you're like me, you'll misspell height. Where the I before E, except after C thing never works. There's a whole lot more exceptions than that. English is a very hard language, yes. So this one is an example of negating a picture. Negating a picture, for you babies in the room, comes from the fact that when you actually had to take pictures with film, the film was developed into negatives, which is the opposite of the true colors, and then you printed the images into real life pictures via using the negatives. Nowadays, y'all just plug into a printer and print out whatever. Not how it worked in the old dark ages. Now, this new blue right here, because my slide got truncated, should actually be on the row above it. So if you're copying and pasting this, which you very well might do because the gate is one of the things you have to do. So you might want to pay attention that this slide is something you might want in your code. So what this does, because it's not C image, we had to put a delay in there to give it some where you can see things happen, kind of thing. That'll go away when we go to C image. But this one's gonna go rows and columns. It's gonna get the pixel out, and it's gonna change the red to the opposite of what it was. Well, the easiest way to get the opposite of what color you have is to subtract it from the highest number, right? So if I have 25 red, and I want the opposite of 25 red, then I go 255 minus 25, and that gives me the opposite. Why? I don't know, it works. It just works. It's that wibbly wobbly color chart thingy. It works. Go for it. So this one gets the pixel. It creates a variable for the new red color, the new green color, and the new blue color. And then it puts into those variables the value of the maximum minus the current. So get red is the current, pixel.get red is the current. And then down here, we're going to create a new pixel with our new colors in it. And then we're going to replace the old pixel with a new pixel. Does that make sense? I lost anybody completely and utterly yet?
Not yet. Keep going.
Logically, it makes sense. I know we haven't created any code yet. I'm not wanting you to create code. I want you to follow me logically. Because we're going to do a lot of logic today, and then next class period, I'm actually going to help you write the gate and the first of the color washing. We're going to do it together. I'm going to videotape it. I'm going to put it out there for the online students and you guys. So you're going to have a starting point to jump off to get through. Hopefully, by the end of this week, y'all will have a good start, if not all of part 1 done. So next week you can ask me questions about part 2 and part 3. And I'm going to be honest with you, a lot of people don't attempt part 3. They get tired of it. They don't want to try it. They don't know what sign it is. I have to explain it. It's okay. But that's the reason it's broken down into points. You can make the decisions how much you want to do based on those points. I'm not going to be disappointed in you if you decide you don't have enough time to do all 3 parts and that you need to go study for your calculus test or you need to work on something else. But make sure the parts you're turning to me work, because I can't tell you how many people in these last projects have turned in stuff going, oh, I did part 1 and I didn't do anything else, but part 1 didn't work. You're not going to get full credit for part 1 if it doesn't work. Please pay attention to things that say you must have this function. I can't tell you how many people have turned in stuff to me, even recently, that they didn't put it in the required functions. If it says create function and I give you a function name, I can guarantee you that when I'm grading your paper, my little checklist over here goes, draw a bus, check, it's there. If it's not there, it's an automatic deduction. Even if you did all the code correctly, it's an automatic deduction. If you put all of your functions inside of main, it's an automatic deduction. Main should only call functions. It should not have functions defined in it the way I've laid out your assignments. If you're calling all of your functions at the bottom of the file and they're not in the definition for main, I'm taking points off for it. I'm not going to give you a 0, but I'm not giving you full credit if you don't know how to use a main function at this point. Let me state this. 1 main function per file. I'm going to say that again. 1 main function per file. If you have defined main more than once, if you have DEF and the word main more than once in your code, you have done it incorrectly. At the bottom, you should have main, open parentheses, close parentheses, to call your main function. If you have that line of code in your file more than once, you have done it incorrectly. And I'm not trying to be mean. I just feel like I have enough people making these mistakes that it needs to be said again. And I obviously didn't explain it well. Questions about that? Online students, if you're watching this video, please send me any questions if you don't understand how main works. All right, now, some things that are a little bit different about these. Because we are having to display the picture, there are some extra functions you're going to have to call to make the display work. You know, the turtle just drew. The pictures are not going to just draw. So there is a draw function, which is the code at the very bottom of the slide. So you're going to have the image dot draw, and then you want it to draw in the window. The window is defined at the top. So you have to, you know, like turtle, we had to create a turtle, we had to create a screen. In the pictures, we had to create an image, and we had to create a window. There's windows can be exactly the same size as the picture, or you can give it some random things. One of the things it asks you to do is to make sure that your window is the same size as the picture. If you come back to the slide, it's done that. You can come grab that piece of code right there and not have to look it up again. Then at the bottom, you have to tell it to draw to the window. And then there's this win.exit on click. If you want that window to close, when you click on the picture, that's what that line does. The reason we put it in there is because it's really easy to have a bunch of these windows open that you forgot to close. And that starts eating up your computer's memory. And if you have an older computer, that's going to slow down your processing because pictures have a lot of pixels in them. If you think about the resolution of pictures nowadays, what are your phones up to now?
Phones out.
Somebody 14 or 15, 48 megapixels, something like that. You know, that's 10,024 pixels times whatever number that was. That's a lot of pixels. Be glad your computers run really fast and the loops do all the touching for you.
And they're gonna have to now.
Yes. So I think the ones that I gave you are kind of lower resolution. So they run a little bit faster if you're on an older computer. If you're on a new computer, it won't matter that much. You won't notice the difference. But anyway, this is negate. These are some logic things I want to show you. We're going to use the C image one, like I said before. You can download it from Courseden. Make sure that when you download it, you put all these files again where we put the pictures in your Python thing at. Python file, only GIF images work. You can say GIFs, I don't care what you call them, GIF. So not all the functions are available in C image that are available in image. If we don't need them, let's take the confusion of that away. Let's get rid of them. You don't have to worry about setting that delay and stuff like that. It's just going to work. So this is the negate using C image. It's pretty much the same. It's just missing a couple of calls that we now don't need. So what I'm going to tell you to do when we come in on Thursday of this week is the first thing we're going to do is we're probably going to open a file. We're going to create a main. And then we're going to copy this off the slide or out of a file that you downloaded. And we're going to start building from there. I'm going to show you it works. I'm going to show you how it works. And then we're going to start building code from there. Sound like a plan?
Definitely.
Questions so far? Has everybody at least read through the project at this point. If not, read it before Thursday's class. And I'm not just talking about read the first part, read the whole thing. Don't try to code it necessarily. If you want to, that's fine. But read the entire thing and make notes on questions you want to ask me. Anything that doesn't make sense, even if it's, I don't understand what you're asking us to do here, that's a valid question. Just because it makes sense to me when I wrote it down does not mean that it makes sense to you. Please ask those clarifying questions. Never be afraid to ask me a clarifying question. And sometimes, as we all notice, I can't type and I put misspelled words in there, or I think I left a word out or something. Let me know. All right, so that's where we're at. We are going to do some refactoring of code. So we're going to copy and paste some of the code from the examples I gave you, refactor it and make it work for us, and get part one well underway. Refactoring means we're just changing it. First thing we're going to do is learn to watch the picture in red. So think about that. If I wanted a picture to have a red tint to it, what would I do to make it be just in tones of red? Lots of R. Lots of R. Yeah. Spot on. So really, when we're watching in red, we're going to keep all the red values. And we're going to get rid of all the blue and the green values. And that's going to give us a red image. So things like that. The fact that you thought that through that quickly, it bodes well for the way we're going. It's not as hard as it sounds. It's going to sound intimidating. It's a lot of code writing, but it's really not as hard as it sounds. Part one is easy peasy. Part two, I think, is pretty easy. Once you get part one done, part two is flows pretty easily. Part three is a challenge, which I intended for it to do, but I will help you if you have questions. All right, let's wrap it up and get out of here for today. And we will hit this hard on Thursday with me actually writing code and you being able to copy it and tell me how bad I type. Please read through the directions, and if you have any questions, come prepared with them. If you want to get started on it, go ahead, but you don't have to. The reason I built it.
Is that a real statement, like, till Thursday, don't spend a lot more time doing?
No, on Thursday, I do not want you to spend hours between now and Thursday on this. I want you to read through the directions, and if you have some brainstorm about doing something, go for it. Get your folder system set up. If you don't have your folder already set up, get it set up. If you're doing everything in here and then transferring it, maybe bring a thumb drive with you where you can just save directly onto it. Or we'll email them out, whatever we do.
Thank you.
If you have questions for me, please stick around.